This is the IM9 instructional video on reviewing how to calculate the slope of a line given two ordered pairs or by looking at a graph. For this instructional video, it will be helpful for you to have a notebook so you can jot down examples and a pencil. Alright, ladies and gentlemen, you might want to take a moment to pause this instructional video and jot down these important notes and the formula for slope for future reference. Okay, the variable that's used to describe or define slope is the variable m. So you will see your teachers, classmates, and even the textbook and Mathia using m. And anytime you see that, especially when we're talking about linear functions, you can assume that that stands for slope. And slope is rise over run. Okay, you might hear your teachers or the book referring to slope as rise over run. And basically that's vertical change over horizontal change. And oftentimes slope is written as a fraction. So even if the denominator is 1, you might still see your teacher or the textbook or Mathia keep the 1 in the denominator just to remind you that slope really is a ratio of two numbers, vertical change to horizontal change. The formula that we'll use for slope when we're calculating the slope of a line between two ordered pairs looks like this. Okay, so slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You might have heard me there saying sub. Sub stands for subscript. So these numbers right here, the 2s and the 1s, those would represent the ordered pair. So for example, if I have two ordered pairs, my x value always comes first, my y value comes second. So here my ordered pair is x sub 1 and y sub 1. Now I might go ahead and fill that in with numbers like 3 and 5. And I would put 1s here just because it's my first ordered pair. And my second ordered pair, which would be x sub 2, y sub 2, might look like this, 4, 6. So then I would plug these values, so these values and these values into this equation. So in the next slide, I'll run through some examples on how to do that. So make sure you have your notebook and your pencil handy for the next two slides. All right, I hope you have your pencil and your notebook handy to jot down these examples. So in these three examples, we're going to go ahead and we are going to calculate the slope of the line that goes through the following ordered pairs. So just for reference, I'm going to go ahead and I'm going to jot down the equation right here in the upper right-hand corner, or the formula, I should say, for slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, when I'm looking at my problem, my two ordered pairs, I like to take the time to label them. So this is the first ordered pair, and this is the second one. So with the first ordered pair, I will label this x sub 1 and y sub 1. And then again, because this is the second one, I'll label this x sub 2 and y sub 2. And I'm sure you remember that the x variable or the x term comes first and the y term comes second in an ordered pair. All right, now I'm going to just go ahead and start substituting these values in. So I'm going to start with y sub 2 minus y sub 1. So my work is going to look like this. Y sub 2 is 5 minus y sub 1 is 4 over, okay, now I'm looking at my x's. X sub 2 is 10 minus x sub 1, which is 3. So I want to put m equals, just to label my work there. Okay, so 5 minus 4 is 1. 10 minus 3 is 7. So my final answer here is my slope, m, is 1/7. So my rise is 1, my run is 7. Or my vertical change is 1, my horizontal change is 7. Okay, now I hope you don't fast forward or stop watching the video. I'd really like you to pay attention to problems 2 and 3 because these two examples are pretty unique. All right, so for number 2, again, I'm going to go ahead and label x sub 1, y sub 1, x sub 2, and y sub 2. Again, I'm going to plug these values in, m equals, so I'm going to do y sub 2 minus y sub 1. So 12 minus 8 over x sub 2 minus x sub 1. That'll be negative 6 minus negative 6. Okay, if you guys remember from 7th grade, when you're subtracting, that's the same as adding the opposite. So 12 plus negative 8 is going to give me 4. And then when I'm looking at my denominator, when you're subtracting a negative, that's the same as adding a positive. That's going to give me 0. Okay, so ladies and gentlemen, anytime I try to divide a value, such as 4, by 0, if you try to type that into your calculator is going to give you some sort of an error because you can't divide something by nothing. So the answer to the slope is not going to be 0, which is the most common incorrect answer. It's actually undefined. If I can write that out here. So if you think back to a graph, or what you know about slope from 7th grade or earlier work that you've done with graphing, anytime you have a slope that is described as undefined, that's going to be a vertical line, a line that goes straight up and down, because there is no horizontal change. So any line that's vertical has a slope that's undefined. Okay, let's go ahead and let's start looking at problem number 3. Just the same as the last two problems, I'm going to go ahead and label my x and my y values, x sub 1, y sub 1, and I'm going to do x sub 2, y sub 2. Same, I'm going to go ahead and plug these values into the formula. So y sub 2 minus y sub 1, 3 minus 3 over negative 20 minus 17. Okay, 3 minus 3 is 0. Negative 20 minus 17 is negative 37. Now you can see in this fraction, similar to the fraction that we just did above, I've got a 0. So you might have a tendency to think, oh, well the answer is undefined. But in this case, you can see the zeros are in different positions. Here it's in the denominator, here it's in the numerator. So they can't possibly have the same answer. So if you were to grab a calculator and divide this out, 0 divided by 37, you would get an answer. You would get an answer of 0. So a slope that would describe a line of 0 would look like a horizontal line because there is no vertical change, and vertical change is the numerator. So these are some very specific cases that you'll need to remember. If you have 0 in the denominator, your slope is going to be undefined. 0 in the numerator, your slope is going to be 0. And one last piece of information to remember with the first example, a lot of times your slope is going to look like a fraction. In the event that you can simplify your fraction, please simplify as always. All right, ladies and gentlemen, this is our last and next example. Now you can see the difference between this example and the last 3 are that this is a graph, and the last 3 I gave you the 2 ordered pairs to calculate the slope of the line that went between the 2 ordered pairs. So what we're going to do here is we're going to still use the same formula for calculating slope. So again, I'm going to put it at the top of my paper just for a reference. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, as you notice, I don't have any ordered pairs. So my job is to look at the graph and pick ordered pairs out. And I want to pick ordered pairs that are going to cause me to have to estimate the least. Okay, so I'm probably not going to pick this ordered pair because it looks like I'm going to have to estimate here. And the jump between 0 and 20 isn't exactly clear. So this would be a pretty big ordered pair to estimate. All right, as with this, I can tell that that's more than 20, but it's kind of hard without some more information for increments to estimate. So I'm going to pick the ordered pairs that I think will allow me to be the closest. So to me, it looks like this here is about 43. Okay, there's a fair amount of estimating involved, but I think that looks pretty close. My first ordered pair is 43. And then my second ordered pair that I'm going to use will be this one. That looks like it's fairly close to 65. Okay, so I'm going to write down that ordered pair, 60, 5. And just like I did in the last three examples, I'm going to take a second to go ahead and label my ordered pairs. Whoops, I almost put a 2 there. So x sub 1, y sub 1, x sub 2, and then y sub 2. So from here, I'm going to do exactly what I did in the last couple of examples. I'm going to substitute those values into the formula. So I'm going to do 5 minus 3 over 60 minus 40. Okay, and that's m equals. Now, before I finish this, I just want to take a minute to point out that another difference between the last example and this one is that I know that 40 and 60 are representing time in hours, and 3 and 5 are representing my population size, in thousand. So because I know what this information represents, I can go ahead and label my answer when I'm finished. Okay, so 5 minus 3 is 2, and 60 minus 40 is 20. And I can simplify that. I can simplify that to be 1 over 10. Now that's the slope of the line. I can go ahead and label my answer. And remember a second ago I said that 3 and 5 represent the population size in thousand. So this represents my population size in thousand, and my denominator, my x values, represents my time in hours. So 1/10 would represent 1,000 bacteria every 10 hours. So it sounds like this bacteria is increasing over time, and I can tell that by the line it's going up as I read it from left to right. So I could write 1,000 per 10 hours. So that's how you're going to take your graph and calculate the slope or the rate of change. You're going to pull 2 ordered pairs out as best as you can without estimating too much. Plug it into the formula and subtract and maybe even simplify. And again, if you know the x and the y values, you can go ahead and write it out in words. 1,000 per 10 hours.